Hello, welcome to the workshop for the Brunei MYCE 2022. This workshop is called the Exploring Data with Python. This was supposed to be held during the 11th of June 2022, but because of some technical difficulties, this was not able to be streamed live during that time. So this is the recording meant for that particular workshop. Yep. So the data that I'm providing, showing here is you can get it from the GitHub page, which is under NOHAZ-H under MYCE 2022 minus explore_data. So you should be able to download, access this GitHub repository. If you want to copy it to your desktop, you can just go to code and then just download the zip. And from there, you can unzip it and then run Jupyter Notebook or Jupyter Lab from that. And if you're familiar with Git, then you should be able to just use the Git command to pull the information from this. Yeah. So if you've done it correctly, you should be able to see the notebook and the data. So the notebook will contain two notebooks. One of it is the blank version, which is what we're going to work through today. The other one is the one that has the predefined or things which has the commands in it. So we'll be walking through the things that you see on this notebook. So if you want to follow on, I suggest for you to use the blank sheet in order to follow through, and then type in the code yourself if you want to follow through. Right. So this is the environment that we're currently working on is called Jupyter Lab. So Jupyter Lab is something that is common in terms of tool for people to use in order to explore data. But before that, let's go on through with the workshop content. So this is the workshop content. We'll be looking into a little bit about Python, why Python, and the main reason why Python is pretty much being used for data science and data exploration in general. We will also be looking at the common libraries for data exploration, things that are common in Python that people are using all over the world. We'll also be looking into making use of data that is available in the public domain and trying to see if we can convert that into something that is useful for our purpose. So that is under the data wrangling side. After that, then we'll be starting to look into a little bit about data exploration and visualization, where we'll be looking at things like statistics, showing graph, and hopefully also going through the modeling part, which is looking into trends analysis. I will not be looking into the helicopter experiment because I don't think that's something that I have the data for, given that this has already been done before. But I'll be talking through what is next in terms of if you want to move on from this particular content. Yep. All right. So Python. So Python is a programming language which, based from the official page, says that it allows you to work more quickly as well as integrate your systems more effectively. It's usually quite popular because it is open source, meaning it's free for use. Anybody can use it. There's no penalty of using it. So you're pretty much free to use whatever it is that or the tools that however you want. It's also considered as the top programming language for data scientists. And this is according to an article in DataCamp, which is quite recent. And the reason why is mainly because it's free. On top of that, there's also plenty of libraries to choose from, and those are the libraries that other people have used and released into the general public as open source as well. So the good thing is you don't have to build those libraries again from scratch. You just have to install it to your machine, and pretty much you're free to use it as well. Not all libraries are free, but most libraries, common libraries, are pretty much free to use. So these are the common Python libraries that are being used for data exploration. Pandas is pretty much one of the #1 libraries. The reason why Pandas is quite useful is because most of the data that is common for people to look into data science are structured data. And Pandas is pretty much a way to analyze structured tabular data. If you imagine Excel, which has tables, or even SQL queries, SQL tables from databases. So those are normally structured. So they have a table, they have a row, they have a column, and they have certain types of the data within them. So those are pretty much the tabular data, and those are quite useful to be for Pandas, because Pandas will have quite a number of nice facilities and features that allows you to make things go faster. NumPy is the other package, which is pretty much what Pandas is built on top of. The idea is NumPy is quite good for the scientific community, because it is able to manipulate arrays, 2D arrays, 3D arrays, multidimensional arrays, those kind of things. And there are also quite a number of optimized features that you can use NumPy for, and we'll be using that as well in the background scenes. Sci-fi is also quite important for the scientific community, simply because there are quite a number of mathematical algorithms that has been optimized to analyze data, and it's also making use of NumPy as the background, and through that it optimizes some of the algorithms in order to make things run a lot faster. Scikit-learn is the other tool that is quite useful, especially if you're looking into machine learning type models. Things like random forests and also clustering analysis. You can use Scikit-learn in order to create models and use Python to run and build models and use them for classification purposes. And there's also other things like regression analysis, regression models that you can use here as well. For neural networks, people tend to use TensorFlow or Keras for neural networks type models, things like convoluted neural networks, convolution neural networks, the CNNs, for typically meant for image recognitions and things. So those are pretty much the libraries that people are using in order to build models and classify them as well. For visualizing the data, Matplotlib is kind of the standard common libraries for plotting. It can do 2D plottings, things like line plots, bar plots. You can even do maps on top of it as well. As well as some 3D plotting capabilities, so you can look data in 3D and rotate and zoom and things like that. So Matplotlib is pretty much the go-to for the basic visualization within Python. Seaborn is the other toolkit that allows you to visualize the data. It's meant for trying to make visualization more attractive, and you can see that from the charts, the default charts that it provides. It's also meant for a little bit more information towards the statistical side of things, so it can show a bit more information than just Matplotlib. But you can pretty much use either one in order to visualize some of the data that you have. So moving on to the data wrangling. So we'll be looking at the data that's available in the public domain. And for this, we can pretty much get the data from the data.gov.bn. So you can see it from here that you can get quite a number of interesting data sets that you can see from here. So some of the data set that the data set that we are looking at is the chicken related data set, which is the monthly local chicken meat production. And from here, what you can do is you can download the file here and save it to your desktop. Now, wherever you run the notebook from, and then you can pretty much read it from there. If you click on this link, what you can see is there are some information about the type of data that's being provided. Sometimes it gives you a little bit more information about how the data was collected and what is meant to be used for. In this particular case, there's no other information apart from its data between 2014 up to 2020. So if you download that and open it, you should be able to see what the data looks like. So this is the data that we're going to use for this workshop. So what we do have is we have the year, and it's pretty much classified as a table. So each year will have its own table, and within the table you'll see the month information on one side. You also have the district, which is pretty much at the top here, as well as the quantity in kilogram, as well as the retail value in Brunei dollars. And you can see this type of pattern repeating again and again for between year 2014 up to 2020. So how do we normally do this without using Python? The typical way of doing this is by manipulating the Excel file itself and making it into a table where it's a lot easier to read and to visualize. This even the way that you have to do this in Excel, you might have to manually select, for example, the year 2014. You have to select the month, which is here, and if you want to display the retail value, then you have to select the retail value. So you select that, you select this, and then you put in a chart. So those are doable while you are doing it yourself manually. However, in this particular case, we would like to do this kind of semi-automated way, so that you don't have to worry about selecting the data. You just want to reformat the data in such a way that it's quite easy for you to get the information for the different districts for the different years or for a specific month, and if you would like to do so, rather than manually selecting things here and there. So that is what are we going to do for this particular workshop, especially for this data wrangling part. So let's try and read the data. So the data, this is the data that we are using. And remember, you can just get the data from the link. So you just copy this link address and you can paste it inside this variable for the data URL. And from that, you can pretty much just read the file on its own directly. What you can also do is you can save it into a file, and that is what I've done. So let's read that and put that in a variable somewhere. So we'll call it data URL, and the location is in data. Yep. So right now we're storing the location of the file inside the data URL, and we're going to use Pandas to read it. So let's use Pandas to read this file. So by default, none of the libraries are being imported automatically. So for this particular case, since we want to use Pandas, so we have to import it into the view. So let's import it and read the data as well. So let's just import Pandas as PD, and we can just run it and see everything is looking fine. And we can now start to read the data inside the variable called data. So PD, read Excel, and data URL, and then we have it. So we are reading the content of Excel, the Excel file inside the data. Let's see what it looks like. And here you do see the information is being read here. However, you can see that the year 2014 is part of the headers, so which is what you see here. But that is something that we would not like to do, especially because we're going to transform this manually and reformat it in such a way that it's going to be nice and easy. So in this particular case, the default behavior is to use the first row inside the Excel sheet as the header column. And what we can do is we can disable that default behavior. So if you go back to the data, the read Excel command, so rather than just leaving it as it is, we're going to put in the header is equal to none, meaning that we don't want to use the first row as the header. And if we run through that, then what you do see is that year 2014 is no longer the header. So it's now everything is within this sheet. So let's show a lot more rows than what we can already see. Okay. So the default behavior for Pandas in Jupyter Notebook is just to display the first few rows and the last few rows if you have the data that's quite big. But we can change that behavior again by using the set option command. So we're going to display the maximum rows to be at 200 and just display the data again. So from here you can see pretty much all the data within this particular view, and you can see pretty much everything. So since we only have 130 rows in the data, so that's why you can see everything in there. All right. So the first thing that you will have to think about whenever you try to wrangle the data is how are you going to display the data and how do you reformat that? And you have to remember on how to structure the data in a way that it is usable. So in this particular case, because the format of the data is quite repetitive, so you'll see the year here and then you see the year here. And if you look at it's always in column number 2. And it's increasing every 19. So the next year would be 19 plus 19, which is 38, which is there. So you can see that there is a pattern within the table itself. So we are going to make use of those kind of patterns in order to transform the data into something that is usable. So one of the things that we can also look at here as well is you can see the district is pretty much here, and the data that we need is pretty much from here to Tong, Blight, and Tumurong. So it starts from column number 3, and you skip one, and then you get Tutong, you skip another one, you get Blight and Tumurong. So let's get the list of the districts first in order to see, to start reformatting the data. So what we can do is we can do data.ilog. So again, we start from column number 2, row number 2, which is here. So row number 2, and we're looking at Brunei Mora, which is number 3, column number 3. And we are going to read 5, column number 5, column number 7, and column number 9. So we are just going to read 3 until 9, skipping everyone. So what we can do is we're going to read 3 to 9, skipping every 2. So we can test that and see what does it give you by just running it. And you can see it starts from Brunei Mora, so that's 3, and then move to 7, to 5, which is Tutong, and 7, which is Blight, and we're missing Tumurong, so we'll just have to add one more. So just say 10, and then you can get Tumurong in there as well. Okay? So that's how we can use the pattern within the data to pull information out. And in this case, let's just convert this into a list. And we'll save it inside the districts variable. There we go. So we now have the districts in the equation somewhere, in the variable. And now let's look into getting everything else. So let's focus on one table first, because that's always the easiest. So let's focus on the year 2014. And what we want to do is we want to get the month, which is this column here, and we want to get the January, which is here. So we want to start off with row number 4, and the row number 15. So we want to get between row number 14 to row number 15, and that is the month. We also want to get the column number 3, the same rows, which is number 4, down to row number 15. And also we also want to get the retail value, which is column number 4 and row number 4 down to row number 15. So we don't need to get the total because that's not really part of the month. We can always calculate that variable later on. So how do we do that? Okay. So let's try to test it, and we'll look at the data. So what we want to get is the location of the data from row number 4 to row number 15. Yep, 15. Because this is Python, and we normally put in an additional one to include the row number 15 as well. So we'll set it to 16. And let's take column number 3 until 4, 5, 6. Because you want to include 3, 4, and 5, and not including 6. And just to check, those are the numbers that we should be getting, and we are. It should be number 2 to include the months. Yep. So you can get the months, the quantity, which is in kilograms, as well as the retail value, which is that. But we have to get it for the different districts as well. So we need to get not just this information, but also need to get one for Tutong, the same one for Blight, and also Temburong. So the good thing about this one is all we have to do is just add 2 in order to move to Tutong, and add 2 to move to Blight, and add 2 more, or skip 2 in order to get to Temburong. So one of the ways to do that is we're going to use the districts. So for so what this will do is it's going to loop through the districts that we have. So if we just say print district, so it's going to show the different districts, and you're creating a number based from that. So let's use that in order to calculate what the things that we want. I'm going to skip the months for now. So let's just say we're only going to read between 3 and 5. So this is column number 3. So 0, 1, 2, 3. And in order to move to Tutong, then we need to add 2 more. So 3, 4, 5. So that means we need, in a formula wise, what we can do is 3 plus the I, which is the number that we go for the district, multiplied by 2, because we're skipping every 2 columns in order to move to the next one. And the same thing with the months. So with the quantity, that's really the value, the retail value. So we're also going to do the same thing. 5 plus 2 multiply by I. So it doesn't matter whether you use I first or 2 first, because in multiplication it doesn't really matter too much. And what we can do is we can just say print, and just to see how it looks like. So what we should be able to see is we should be able to see the different data is being printed differently. So you can see the quantity for the first one would be, for Brunei would be 787. For Tutong would be 568, 69. For Blight would be 687, and for Temburong would be 10. So just to double check that here, since we're only looking at the first year, So 787, 569, 687, and 10.3. So that is exactly what we get here. Yep. So there's a typo there because I'm overwriting the district variable, which I shouldn't be. If I just do that, then it will look true. And there's, since I was overwriting it, so my district is no longer correct. Just if you want to test that, you can see what the district is now, which is just a G, so that is completely wrong. So let's rerun the calculation of the districts, and then we'll run through the script in order to pull the right information. As you can see, where the Mora now is having that information, Tutong will have this information, light and Tamburon. So bear in mind, this is only for one a year, which is year 2014. So we need to be able to capture the year for this particular data. And what I've already mentioned before, that the year you can get it from this particular location. So from column number 2, start off from row number 0, and then move on to row number 19, and row number 38, and so on. So what we can do is see if we can pick up the right year for that one. So the year should be the data. So we're only looking at the year 2014. So we'll be looking at the row number 0, column number 2, and then we can just print it first to see what it looks like. And I'll hide the previous one that we generated. Yeah, so you can see that since we're not changing the year, we're only looking at just 1 year, this is not really changing too much. So we can pretty much put this outside of the loop of the districts because it shouldn't change. And from here, you should be able to see that there's only year 2014. But we don't want to see just year 2014. We want to just see the number. So what we can do is we can do a split. Just look at the last 4 letters. And then you can see that it's just picking up the last 4 letters within the year 2014 and only pick up that number. So we now have the year. And we'll store that in the year variable. But what we need to do is we need to loop it for the many years. What we can do is we're going to create the loop called row number, and we'll start from row 0, and then we'll go through, let's just say 130, row number, the number 130, and we know the increment of that year is every 19, so we'll put it there. And then now the year should be the row number plus the 0, which is the starting point. So if you print the year, row number, you should be able to see the year is now changing. Yep. And what you can also see here is the data is also different for different years. So for Brunei, the first 2014 would be 787 in January, and then moving to 2015, 77 as well, and 16, 77. So the reason why it's always the same is because we haven't added the row number. We haven't made that change in order to move from the first table to the second table for the different years. So we need to add that here. So in this case, 4 plus the row number, similar to what we've done with the year, and then also the 16. And what you should see is the number should be different. So now 787, and then the next number should be 908. So it has already changed for Brunei. Then moving to 2016, you have 914. Just to double check, let's just look at the Excel file. So 787, 908, and 914. So that's how we're able to move from moving from the different tables within the data. Yep. So how do we get the month now? So the month is similar to how we get the year. We are only going to look at the months. Let's look at the first one, so data.ilog. So the location of the month is just looking at the first table. It's in column number 2, from row 14 to row 15, or row 4 to row 15. So we can add that here. So we'll just take that one for now. Um, 4 to 16, because we want to include 15, and column number 2. Then if we print the month, so you'll see that we are able to pick up the month column. What we can also do is we can move to the different tables, not just 2014 table. So we just add the row number in order to move to the next table and pick up the right month. It shouldn't matter too much because the month is always the same regardless of which table you got. But yeah, just to make it a lot more consistent, this is what you can. All right, so now that you are able to pick up some of the data, then it's time to combine it into a Panda data frame in order to make it a lot more easy to read. So let's call this data edit. Let's make an empty data frame. So we already got the year, we have the month column, and then we need to know the district, which is just district. So we have that information. And then we also have the data that we need. So let's just call that. Okay. So we'll call the data that we read as subdata. So subdata is equal to that. So this subdata should be this one here. Just to check on what subdata is. So we're going to check type subdata, and we're just going to print what it is, just to double check what kind of data is it. So it is already a Pandas data frame. And then what we can do is say subdata columns is equal to. So the first one would be the quantity in kilogram. So we'll just type it. And the second one is the retail value in BNB. Then let's have a look at what is being created. You print the subdata. So now you can see each one of them will have the quantity label as the header, as well as the retail value in BNB as the header. Okay. So once we have that, then we can populate the data more. Let's just call the subdata district is now the district. We don't have to print this anymore. Missing the code. So now the district, I will have that information. Then what we need to add is the month. So subdata month is equal to the month. Now you can see the months in there, and then the district, which is Tutong, and then the months in there. We also need to add in the year so that we know which year the data is coming from. So now each year, each table will be different. You will have the year, the month, the district, and the associated values like the kilo quantity and the retail value. So we are almost there. All we need to do is just collect all this information into a single table. So what we need to do is we're just going to say data edit is equal to concatenate with the subdata that we created. Then you can see what the data is being created. You just don't need to print anymore. Yeah. So now we have the table with the quantity, retail value, the district, the month, and the year. You also notice that there are now 336 rows, even though the index is that. So we need to reset the index because it copies the index from the original table. So we're going to do reset index. Gonna ignore the previous index, and then we're just going to overwrite the same data. Now we have a running index number, and we have the data, which is in something that is easier to manipulate. Okay, now that we have managed to transform the data into something that is usable, let's start to explore the data. But before that, let's look into some theories. So this is a standard statistics plot. For people who have done statistics, this is probably quite common. This is the typical box and whiskers plot. Based from this information, it tells you the distribution of the data, where is the median, mean, the interquartile range, and things like that. But then what are the terms? What do the terms represent? So the mean is probably the most common term for within statistics. What it is just an average value of the distribution. So you take all the numbers, you sum them, and you divide it by the number of items, the number of numbers that you have, and that is pretty much the mean. The median is the midpoint value within that distribution of numbers. So it doesn't have to be exactly the same as the mean. It's only going to be true for a typical normal distribution or Gaussian distribution, where the mean will be equivalent to the median. Otherwise, the way you calculate the median is you sort the number that you have, and whatever that falls in the middle will be the median. The sigma, or the standard deviation, is also a common measure within the distribution, within statistics. What it does is it tries to give you a sense of how much spread your data contains around the mean. So for a standard normal distribution, this is pretty much where your data is being distributed according to the standard deviation. So most of your data, about 68% of your data, will fall between ±1 standard deviation of your data distribution. About 60, about 80, let me see, about 95% of your data will fall between the ±2 sigma, and about 99.7% of your data will fall between 3 sigma. So those are quite important to say that about where your data is, how common your data is going to be if you have a number within the distribution. In order for you to be, it is going to be quite useful in order to identify whether the data is an anomaly, which is quite different from the rest, or it's a common number is within your typically 2 standard deviation, which is about 95% of your data. Quartile 1 and quartile 3, or first and third quartile, is essentially the same as the median, but rather than looking at the middle, which is 50% of your data, you look at 25% and 75% of your data after you sort them. So again, you sort the data, your numbers, and then you pick the rather than the middle, but 1/4, and that's 125%, and 3/4, that would be 75%. That would be quartile 3. Again, it just tells you your spread of the spread of your data. Interquartile range is making use of the 2 quartiles, which is the first and third quartile, and then just calculating the difference in the values. So we typically use interquartile range in order to get an idea of where outliers are. So typically outliers are 1.5 times more than the third quartile, and anything that is lower than the quartile 1 minus 1.5 times of the interquartile range. So anything away from that is considered outliers, as indicated by this whisk box and whiskers plots. So typically, the median is represented in the middle here, which is the line there. Quartile 1 is here, quartile 3 is there, and this is the interquartile range. The outliers is anything after quartile, this point here, which is quartile 3 plus 1.5 multiplied by interquartile range, and also anything lower than this one here. So outliers are definitely useful in order to look into, because they're a bit different than your standard data. So that there would be typically something that needs to be looked at from that. The question is, does it mean that all outliers are bad? Not necessarily. It depends on how the problems that you have. So typically outliers are things that are different. Whether that is a bad thing or a good thing, that will depend on what you're trying to look for. This indication is just aware of saying, okay, there's something weird or different if you look at this data compared to the rest. So that means you need to investigate a lot more on why they are being outliers in the first place. Maybe there was something wrong with the way the data is being recorded. Maybe there was the anomaly that you're looking for that you need to detect. So there could be reasons why they are being outliers. And those are the things that you typically need to watch out for, as well as you need to do a lot more further investigation on why they are being outliers. Okay. So that's it in terms of the theories. So let's try to display the data. Since we already have the data, what we can do is we can use the info within Pandas in order to see the information that we have in there. What we do see here is there are 366 values. It's not null, so that means it's not empty. And we have a total of 366 rows in there. So that means there are no null values, empty values within the data that we have. What you can also use, the describe command. So describe commands will tell you a bit about the count, the unique, and the number of unique values in the data, the top most common one, as well as the frequency. What you do see here as well is that it doesn't really do the proper statistics for the way we expect it to do statistics. For example, the quantity in kilogram and the retail value in Brunei dollars. So those are typically numbers that you should be able to get things like the minimum, the median, and the mean. However, by default, because it recognizes those numbers as an object, not as a number, then it doesn't actually provide that statistics by default. So what we need to do is we need to fix that in order to make it recognize it as an integer. So let's do that. Okay, so data. So what we're going to do is we're going to just read the quantity. Sorry, out the comma. So read the quantity. We're going to read the retail value. Now we might as well just convert the years as well. And what we're going to do is convert that into floats. So I'm going to do the data describe pattern again. Let me see. Oh, sorry, my mistake. This anymore. Yeah. I'll just do the info to check whether it has indeed changed. So it still recognizes it as an object. So why is that? Oh, let me see. It doesn't really convert it because I put it in code, so it thinks it's just a string. So now we are calling it as a float, and we should be able to see it converted into that. Doesn't seem to work. Oh. Right, I managed to find out what was the problem. So I added the .loc here, which you don't really need. So now we should be able to convert the quantity and the retail value into a float as indicated by this information here. And as well as you can get the describe, and you should be able to get things like the count, the mean, standard deviation, the minimum, the maximum, and things like that. So that should be okay. Then the next thing is to look at the different values for looking at the different values of the district as well as the month. So what we can do is we can just do print of the data edit to district, and then we'll get the value count how many times that any particular value is being used, and also, as well as looking at the different unique values that are available in there. We can also do the same thing with the months. So we should be able to see that the districts, there are only 4 different kinds because we knew that's what we put in. As well as the year, there should be only January, February, March, April, May, June, July, August, September, October, November, December. So it should be 12. And each of them have 28 entries under it. So this is the year from 2014 to 2020 multiplied by 4. So because there are 4 districts in there. So that's why you get 28. Okay, so that's how we can display the data based on the table itself. We can start to look into plotting the information as well. Okay, for that we are going to use Matplotlib because it's the common tool to use. So the standard way of doing it is calling it as importing it as PLT, which is a short form for everything, and that is always going to be quite useful to use later on. Because you don't have to type matplotlib plot again and again because it's quite long. So using PLT should be good enough, as you can see here. Okay, let's set it up. So let's check what is the years. So there's no years. We're going to use the data to calculate what is the years available. So we only have data from 2014 up to 2020, which is correct. So we have 1, 2, 3, 4, 5, 6, 7 years in total. Let's plot the quantity. So how we're going to use Matplotlib is we're going to create a figure and an axis. So we're going to plot subplots. Let's just use 2 for now, because we are going to plot the quantity as well as the retail value in 2 rows. So let's just do that. And there are 4 districts, so we can say the districts should be land districts. So we already have the districts as a variable, and we're just going to share the x-axis to be the same, and we'll set the figure size to be 5826. See how that. Okay. So that's the way to set up the data. Since we are going to look through the years, so we'll need to create a variable, a loop based on that. So we're going to call it y and year. And enumerate the year. Okay. And so what we are creating now is we're creating a loop of the year, and we're creating a plot. So if you just do a plot show, there should be nothing there. All you're creating is 4 districts horizontally, and then 2 for each year, and then you're going to create more for the number of years that you have. So that's pretty much the setup that we have. And let's populate the data now. So for, just call it D for districts in the district. So data to plot. Let's just select the data edit. Query, so the year. So we're only going to select the year, which is the same as the year. And we're going to select the district. Which is the same as our variable district. So that is the data. And just to make the labeling a bit easier, so we are going to call the axis. So the first one is going to be the district. Call it the year. So we're going to plot the year as the title and also the district. And since the top row is going to be on quantity, we'll just call quantity. And we're going to do the same thing for the second row, this one. And we're going to call this retail. Now, if you run this, so you should be able to see where the data is the year. Let's make the year as an integer, because I don't like the decimal places for the year. 14. For Nemara, Tutong, Black, Temurong, you have the quantity, and then you have the retail value, and then you have total 15, 16, 17, and things like that. So that's setting up the plots. In order to plot the actual data, then what we can do is we can do this. So we're going to use the data plot, and I'm going to plot bar. We're going to use the months as the x-axis. The y, we are going to use the quantity. And then the axis that we're going to use is the axis. So it's going to be the first one because it's quantity, the top, as well as the which districts it belong to, which is D. We're going to use the color red, so that is easy to see. And let's just turn off the legend. For the other one, we're going to use retail, value BND. It's going to be the bottom row, and we're going to use blue. Running through that, you can see the different charts. So this is one way of visualizing the data. You can pretty much automatically plot everything in one go, just because you have set up your data in such a way that it's quite easy to manipulate. However, just because you are able to see the data, it doesn't necessarily mean that you are going to see problems with it. Just because you have quite a lot of data to look at, sometimes it's hard for you to focus on or identify very, very quickly issues with the problem that you are currently working on. I would be very surprised if you can see what is the problem just by looking at these charts here. Doesn't seem like there's anything wrong with it, because the numbers seems to make sense. Everything is around about the right order. Probably Temburong is not generating as much chicken compared to the rest. Minamara has the most in terms of quantity, and Blight would be second on average, and Tutong would be third on average. So, I mean, first look, there doesn't seem to be anything wrong with it. So this is part of the reason why feature engineering is going to be quite important. What it does is it tends to highlight certain features of your data that you would otherwise be very hard to identify in the first place. So let's just calculate the price of the chicken per kilogram, just to see what is whether that makes sense or not. So data edit, I'll call it unit price, AND per kilogram is equal to the data edit with the retail value is and that is divided by the data edit divided by the quantity. And let's display that data edit is price So this is the statistics, the information about the unit price of Brunei dollars per kilogram. You can probably see already there is one, well, it's quite obvious that there's already a problem. If you look at the numbers, so the average price of the chicken meat per kilogram is on average about $4,660 Brunei dollars. So that is already something that is wrong, because we know that the price of chicken is around about $4 and something, should be at least per kilogram. So we do know there is something wrong with the data. Then what we can also do as well is we can plot the information as well. Okay, so let's plot it. So we're going to use the same thing like we did just now. So we're going to use figure and axis. Subplots, we're going to use only just one row, and we're going to do the length of the district. Share x equal to true, share the x-axis, and the figure size, fixed size is equal to, let's make it 20 by 6. And let's look it for the year. And let's plot it per district, similar to what we had earlier. And plot data plot. Data for plotting would be the data edit query. Let's look at the district and the year. With a plot, we're going to use a line plot for this particular example. You need to see the months as the x-axis, the y as the unit price per kilogram. That's axis B to indicate which district you're in, and we're going to label it as with the year. And we're going to set the title. And this is the plot. So from this, what we can say is for Brunei Mara, Belait, and Temburong, you see the exact same pattern. However, there's something wrong with Tutong. Tutong seems to be having a much larger, much higher unit price of chicken per kilogram. So that is something to be investigated. So one of the things that we need to look at is this particular year, which is 2018, for the Tutong data. Yeah. So what you do see here is the quantity seems to be okay. It then looks to be within the right ballpark. But if you notice the 2019, where the quantity of Brunei Mara chicken produced in Brunei Mara is about 1,000 or about 900 on average, whereas Tutong is around about 500 kilograms on average. But if you look at the retail value, they are exactly the same. And we do know that the unit price for the chicken is correct for Brunei Mara and Blight and Temburong. So we are suspecting that there's something wrong with the Tutong retail value, as it looks exactly the same as Brunei Mara. So it's not the 2018 as the problem, it's actually 2019 based on the colors. Yeah. So let's try and fix the wrong retail value for in 2019. So let's create a flag for 2019. Edit the year is equal to 2019. And So you want to identify which part of the data is related to Tutong and which is related to 2019. And we are going to use the data from below as to replace the values for the one in Tutong. All right, so we're going to fix the Tutong value. So we'll first select the Tutong and retail value is what we are going to fix. And how are we doing that is we're going to take the data and select the right people, and we are going to take the quantity in kilogram because we know that is correct. Convert into NumPy, and then we will multiply that by the unit price from the line. Yep. So that will fix the retail value for total. And then the other thing is we notice that there is the value of the unit price is about 4,000, which is about 1,000 times more than the expected value of a chicken. So looking at the data and other data within the data.geophysicist, the most likely explanation for that is the units for the quantity is not in kilograms, but it is in tons, and tons is actually in have the unit conversion of 1,000, 1 ton equivalent to 1,000 kilograms. So hence you have the values multiplied by 1,000. So let's fix that. Let's fix the quantity in kilogram. Is actually the data edit quantity multiplied by 1,000. So that will fix the units conversion to be correct. And then what we're doing is we're recalculating the unit price again, so we can just copy what we've done before and then just paste it here. Just run it. And we're going to again use the same plotting to see whether we fix anything or not. Now you can see that the charts looks the same for all the districts, and there's no other anomalies that you can see from here. And now the unit price in BND per kilogram of chicken meat is now with about $4.5, which is the number that you would expect compared to 4,000 Brunei dollars. Okay, now that we have fixed the data, it's time to have a look at what else can we get from the available data that we have. Let's use Seaborn for now compared to the matplotlib that we've been using before. And let's try and plot the distribution of the unit price over the years for all the districts. So as usual, since Seaborn is not the default module, let's import it into the project. So we are using SNS as a shortcut to call Seaborn. Let's fix the size of the figures that we are going to create. Just make it 20 by 5. And let's use Seaborn. So we are going to use the data edit, and we are going to use the year as the y-axis, the x. We are going to use the unit price, and we are going to orient it to the horizontal. We're also going to title it, give it a title. I missed the column or the quote. So this is now the plot of the distribution of the unit price over the years. What you do see, if you remember the distribution, the box and whiskers plot, there are quite a few anomalies for the different years. You can also see how the price varies, the unit price varies across the years. Now I just look at it from a district point of view. We are going to use the same data. Rather than plotting the y as the year, we are going to use the quantity in kilograms, and for the x we are going to use the district, and we're going to color it based on the year, and we are going to call it, give it a title. So you can see here for Brunei Mora, the distribution of the quantity. There's an obvious anomaly, which is in 2017, where the quantity is lower for some reason compared to the rest. Tutong and Blight have similar distribution, although Blight has a lot more variation compared to Tutong. And we also see Temburong is the lowest among them. Let's zoom in to Temburong in order to better see what the data should provide. So let's just query the district. Since we only need to see tomorrow data, we'll just look at it at that. And for tomorrow, did I miss something? Quantity. Oh, it should be double equal to. And this is distribution of the quantity of chicken meat produced in tomorrow. So overall, it's around about 1100 or 11,000 kilograms over the years. Yep. So that is how we can use seaborne, especially the box plot view, in order to look into further detail some of the data that we see, and we can have some sort of idea of what conclusion we can draw from this. So for now, we have pretty much looked into the data exploration side of things. We have also looked into wrangling the data in order to be able to be analyzed through the use of Python. So typically next, what you want to do is you want to try and model the information that you see in the data. And there are many different ways where the data can be modeled. It all depends on the problem that you have in hand. So if you have some questions that you need to be answered, how you answer it will be done through the modeling. So in this particular case, the question that we want to look or to ask is the meat production increasing over the years? And if it is increasing, how much? So what we can do is we can try and plot the sum of the total meat production over the years and just look at it as a graph. That would be something that we can do right now. So we are going to use the data edit, and we are going to group the data by year. And we are going to sum all the months within the year in order to get a proper picture of the yearly production. And we are only going to look at the quantity in kilogram because that's the metric that we are looking for, and we can just plot it. Did I miss? It should not be sun, it should be sum. And this is the plot. So you can see that there is periods where it is increasing, decreasing, and it depends on which year you're looking at. So the typical question with this is this enough to say yes, there's a slope or not? Visually, you could say that it is increasing. However, since we're using data and statistics, people tend to use hypothesis tests in order to verify whether there is indeed an increase in the quantity of chicken being produced. So if you look at it simply, since we wanted to look into the amount of meat being produced over the years, if there's any increase, we typically tend to look at linear regression. Linear regression is a way for you to be able to fit a straight line through the data points that you have, and based on that data point, see whether you could say there is a linear slope in the data, and see whether that linear slope that it predicts is really significant enough for you to call that there is indeed an increase. How much? So it kind of gives you some sort of a confidence rating on the slope that you see. So typically with linear regression, you tend to get the slope, which is what we need. We also get the intercept, which is also another parameter that you tend to use for linear regression. for this particular example, we'll only be looking at the slope. We also have this thing called the R-squared, which is the measure of how predictable the data in the Y is based on the value of X. Very high number, which is typically 1, means that this is very predictable. If it's 0, meaning that it cannot find a reliable predictor based on the value of X. The p-value is something that people don't tend to use, but it is there as part of the formula. It tells you how significant or how much you do trust the data that is telling you that there is indeed a slope. So it's more of a confidence rating. Typically, people tend to use an R-squared of 0.8 or 80% in order to say that there is indeed some sort of a correlation or some sort of a relation between the X and the Y value, where as well the p-value, people tend to look at the 5%. So anything less than 5% means you have less than 5% chance that it is indeed something that is slope to be there, so to be present. So you are very confident in that. But if it is more than 5%, that means that you have not as high of confidence in terms of saying there is indeed a slope or not. So for the p-values, the lower the value is, the more confident you have on that, on the value that you see. Anything more than that, the higher it is, then the less confident you have. So for this particular example, we are going to use the linear regression to test our theory. We are going to use the null hypothesis, being that there is no slope in the data. The alternative to that one, which means that the null hypothesis is wrong, then what it means is that there is indeed a slope in the data that you see. And the p cutoff value is typically set before you actually run the test. Like I mentioned before, the value is usually around 5% or 0.05. For things that are a lot more safety critical, people tend to use a much higher or much lower value, around about 1%. So it depends on which application or use case that you have. But for our purpose, we are going to use 0.05, which is 5%. For the linear regression, we'll make use of SciPy. It has a ability to calculate the linear regression function for us, so we don't have to code it ourselves. Let's import SciPy. We're going to import linear regress in order to have that function to be there. I'll copy this one. So this is the value that we have. So the X value is that. And since what we're looking for is the year as the X value, we're going to look at the index, whereas the Y is the actual values that we want, which is the quantity. If you just want to check what the values is, so X is essentially just the year, whereas the Y is the sum of the quantities within the year for those years. So we are going to use the linear regression, and we are going to print the values for the P. And we're just going to give it 4 decimal places. Yeah, 4 should be fine. We are going to do the same thing, and rather than show the p, we're going to show the r squared. Let's make this look nicer. And the p-value should be r value. And then we are going to show the slope. Okay. So based from the linear regression, we have a p-value of 0.0544, which is more than the p-value cutoff that we specified earlier. What it means is we cannot reject the null hypothesis, meaning that our data does not give us the confidence that there is indeed a slope. Even though the R value is also quite high, but it's still less than 0.8, so it's also less relevant. So if you look at the chart, this table here, we are within the less relevant and not significant side of things. Even though we do calculate the slope, but because of the data that we have, we cannot say for certain that there is a slope within the data. So we can only say there is no slope based on the data available. So even though visually we can see some sort of a linear increase in the quantities over the years, but due to the lack of data that we have available, we cannot say for certain that there is indeed one. So what is next? So far, based on what we've been working through, we only been looking at one data source, so one Excel file. Things will start to get a lot more interesting once you have more than one data sources. Typically, things that you have to solve are how do you merge those data together, given that they're coming from different sources. Another important thing that you need to think about is what features can you derive from them. Now that we have access to multiple sources of data, you have more information to play around with. What are the extra things that you can see compared to just having one data source? However, that's not the final thing to think about. There are also things like, is it enough for you to be able to solve your problems, even though you have access to more data? More data doesn't necessarily mean it's good. It's only going to be good if you can use those extra data to solve the problem that you have or give you more insights. So that is some of the few things that you can start to think about once you have more than one data sources. There are also other things that you can do and look into is the kind of statistical model that you could use. I've already showed you one, which is the linear regression. Other models that you can use are things like ARIMA models, which are meant for time series data. These kind of models are very useful, especially if you're trying to look into forecasting and anything that has a time element within the data. So you want to predict the future. Classification is also something that is quite often being used in data science. The idea being that you can use classification in order to break your big data into smaller chunks by grouping similar things together in a way that will make things a lot simpler because you have less things to worry about rather than having too many data. So it's a curse of having too much data. So classification typically tends to help out in making the data a lot more manageable. So some of the key takeaways that I hope you are getting out of this workshop is don't just trust the data as it is. You always need to understand and verify whether they are correct or not. In this particular case, we saw that the quantity is not exactly have the right units. And also there is something wrong with the data input in the Tutong data set. Always tries to learn from the data. There's a saying that let the data tell you the story, let the data speak for itself. And you can only do that by making use of the power of statistics to back it up. So you can't just infer things based on what you see without having the necessary statistics in order to prove that. I hope that you will get the sense of how to do data exploratory within the field that you're looking at. So this is just one way of doing things in Python. As usual, there are many ways to do this, not just using Python, but also other languages as well. So hopefully this will help you in for you to start to explore your data based on the data that you have access to, and hopefully you'll have fun looking at it and get more insights out of the data. Thank you for listening.